Have you ever really stopped to think about our planet's climate? I mean, it's not just about the weather forecast. It's this incredible story of invisible forces, these giant powerful levers, and, well, these secret architects that are shaping every single day of our lives. So, how does it all actually work? Let's dive in and find out. To really get our heads around this, let's start with a bit of a mystery. How on earth is it possible that on the exact same day, in the same country, one place is baking in a scorching 50 degrees Celsius, while another spot is enjoying a perfect, pleasant 22 degrees? I mean, it's the same country, under the same sun, so what's the secret? What is really going on?
Well, to solve that puzzle, we first got to crack the code of our atmosphere. And that means getting a really clear picture of the difference between two words we throw around all the time, but often get mixed up: weather and climate.
I absolutely love this analogy. Just think of weather as how a single student did on a test today. It changes all the time, right? Up and down. But climate is the entire class's average grade over 30 years. It's the big picture, the long-term, established personality of a place, built from decades and decades of daily weather.
But here's the interesting part. Even though they work on totally different timescales, both weather and climate are built from the exact same 5 ingredients. You've got temperature, atmospheric pressure, wind, humidity, and precipitation. These are the fundamental building blocks for everything, from a single drizzly afternoon to a desert that's been bone dry for centuries. So, that leads to the big question. If the building blocks are the same everywhere, why are the results so wildly different? Well, the answer lies in 6 master levers. These are the real, unseen architects of our world. These are the climatic controls that decide why a place is hot or cold, wet or dry. Let's take a look at the first one. Okay, first up, the big one. The most important control of all is latitude. And this is really just how far north or south a place is from the equator. You can honestly think of the sun as the father of the entire climate system, and latitude basically decides how much of its powerful energy your specific spot on Earth receives. And this slide shows you exactly why that is. See, because the Earth is a sphere, sunlight hits the equator directly, like a super focused flashlight beam. It's intense. But as you move towards the poles, that same beam of light gets spread out over a much bigger area, so you just get these weaker, slanted rays. The main takeaway here? More direct sun means a hotter climate. It's really that simple. All right, let's move on to our second master lever, altitude. This one's pretty straightforward. It's just how high up you are from sea level. As you go higher, like climbing a mountain, the atmosphere gets thinner, it can't hold on to heat as well, and so the temperature drops. And here is a perfect real-world example to lock this in. Take Amritsar and Shimla in India. They're on pretty much the same line of latitude, so they get the same dose of sunshine. So why is Shimla always so much cooler? Altitude. It's not about the sun's angle. It's just about being way higher up in that thinner air. That is altitude in action. Okay, control number 3. This one is the engine of our atmosphere, pressure and wind. And this is where things get really dynamic because it's all driven by a super simple fact of physics. Hot air rises and cool air sinks. So let's just walk through this cycle. First, the sun heats up the ground. The air right above it gets hot, it becomes lighter, and it rises up just like a hot air balloon. That creates what we call a low pressure zone that's kind of empty. Meanwhile, somewhere else, cooler, denser air is sinking, creating a crowded, high-pressure zone. While nature always tries to balance things out, so air rushes from that crowded, high-pressure area to fill the empty, low-pressure area. And that movement, that rush of air, is wind. Now let's move to our next control, and you'll see how these start to connect. It's all about a location's distance from the sea. You can think of the ocean as a giant, slow-to-change thermostat for the planet. It takes a long, long time to heat up and a long, long time to cool down. And this creates a massive difference in daily life. Coastal cities like Mumbai have their temperatures regulated by the sea. That water keeps them from getting crazy hot in the summer and freezing cold in the winter. But inland cities like Delhi, they're too far away to feel that effect. They get those extreme temperature swings, what geographers call continentality. So, the further you get from the ocean's calming influence, the more extreme the temperatures get. Number 5 is a huge one, ocean currents. Now, we're not just talking about waves near the beach. These are massive, continent-sized rivers flowing within the ocean. They act like a global conveyor belt, moving warm water away from the equator toward the poles and bringing cold water from the poles back down. And here is a totally fascinating paradox. Have you ever wondered why so many of the world's biggest deserts are right on the coast, next to a gigantic ocean? Well, it's often because a cold ocean current is flowing right past the shore. Cold water doesn't evaporate easily, so that means there's no moisture going into the air, which means no clouds and no rain. The ocean itself is literally helping to create the desert right next to it. How wild is that?
And that brings us to our sixth and final control, relief features. This is all about the physical shape of the land. Giant mountain ranges don't just sit there looking pretty, they actively get in the way. They block wind, they force air up, and they can create completely different climates on one side versus the other. So we have our 6 controls, right? Latitude, altitude, pressure and wind, distance from the sea, ocean currents, and relief features. Now, let's put it all together and go back to our original mystery by using India as a perfect case study to see them all in action.
Let's start with relief. You see, the Himalayas are so much more than just mountains. They are India's giant bodyguard. They form this massive wall that physically blocks the freezing, bitter cold winds that try to sweep down from Central Asia every winter. Seriously, without this enormous relief feature, northern India would be a much, much colder place.
And this is where it all just clicks into place. Look at how these different controls create completely different worlds inside just one country. Jaisalmer is a hot desert because it's far from the sea. Classic continentality. Mumbai is tropical and wet because it's right on the coast. Meghalaya gets some of the highest rainfall on Earth because its mountains physically trap the monsoon clouds. And Ladakh is a cold desert because of its super high altitude, sitting in the rain shadow of the Himalayas. You see, different combinations of controls create totally different climates.
And this incredible interplay of all these controls doesn't just create different places, it also creates a distinct rhythm through time. It creates the seasons.
In India, this rhythm is especially dramatic. The cycle starts with the intense heat of summer, which creates a huge low-pressure system over the land. This acts like a giant vacuum, pulling in moisture-packed winds from the ocean, and that triggers the famous monsoon rains. Then, as the land cools down, the winds reverse, leading to a clearer, cooler winter, all being protected by that Himalayan bodyguard we talked about.
So when you really step back and look at the big picture, you see that our climate isn't random at all, not even close. It's a magnificent and delicate dance, a predictable, understandable system governed by this beautiful interplay between the sun's energy, the shape of the land, the movement of the air, and the vast, deep memory of the sea.
We've just gone over the rules that have choreographed this dance for millennia, which of course leads to one final, very important question for you to think about. Now that you know the rules of the dance, how might we be changing the steps?